There are several methods of sampling from a population. In this video, we'll look at simple random sampling and systematic random sampling. Simple random sampling works like a raffle or a lottery. We start with our population of raffle tickets or lottery balls and randomly pick them out one at a time. In our coffee ratings dataset, instead of raffle tickets or lottery balls, the population consists of coffee varieties. To perform simple random sampling, we take some at random, one at a time. Each coffee has the same chance as any other of being picked. When using this technique, sometimes you might end up with two coffees that were next to each other in the dataset, and sometimes we might end up with large areas of the dataset that were not selected from at all. We've already seen how to do simple random sampling with pandas. We call .sample and set n to the size of the sample. We can also set the seed using the random state argument to generate reproducible results, just like we did with pseudo-random number generation. Previously, by not setting random state when sampling, our code would generate a different random sample each time it was run. Another sampling method is known as systematic sampling. This samples the population at regular intervals. Here, looking from top to bottom and left to right within each row, every fifth coffee is sampled. Systematic sampling with pandas is slightly trickier than simple random sampling. The tricky part is determining how big the interval between each row should be for a given sample size. Suppose we want a sample size of 5 coffees. The population size is the number of rows in the whole dataset, and in this case, it's 1,338. The interval is the population size divided by the sample size. But because we want the answer to be an integer, we perform integer division with 2 forward slashes. This is like standard division, but discards any fractional part. 1338 divided by 5 is actually 267.6, and discarding the fractional part leaves 267. Thus, to get a systematic sample of 5 coffees, we will select every 267th coffee in the dataset. To select every 267th row, we call .iloc on coffee ratings, and pass double colons and the interval, which is 267 in this case. Double colon interval tells pandas to select every 267th row from 0 to the end of the data frame. There is a problem with systematic sampling though. Suppose we are interested in statistics about the aftertaste attribute of the coffees. To examine this, first we use reset index to create a column of index values in our data frame that we can plot. Plotting aftertaste against index shows a pattern. Earlier rows generally have higher aftertaste scores than later rows. This introduces bias into the statistics that we calculate. In general, it is only safe to use systematic sampling if a plot like this has no pattern. That is, it just looks like noise. To ensure that systematic sampling is safe, we can randomize the row order before sampling. .sample has an argument named frac that lets us specify the proportion of the dataset to return in the sample, rather than the absolute number of rows that n specifies. Setting frac to 1 randomly samples the whole dataset. In effect, this randomly shuffles the rows. Next, the indices need to be reset so that they go in order from 0 again. Specifying drop equals true clears the previous row indexes, and chaining to another reset index call creates a column containing these new indexes. Redrawing the plot with the shuffled dataset shows no pattern between aftertaste and index. This is great, but note that once we've shuffled the rows, systematic sampling is essentially the same as simple random sampling. Let's get